Welcome to your deep dive. Today we're going to be venturing into large language models.
Okay.
Those AI systems that are really
Yeah.
changing how we interact with computers.
Yeah.
You're really keen on understanding RWKV,
Right.
a new architecture that's vying to shake up the landscape dominated by transformers,
That's right.
like the ones behind ChatGPT.
Exactly.
So we're going to be using the Feynman technique to unpack this complex topic and make it crystal clear.
I love that approach.
Yeah.
Ensures that we understand not only the what, but also the why behind RWKV's mechanics.
Exactly.
Yeah.
To start, let's set the stage a little bit.
Okay.
Think about your phone predicting text or your smart speaker answering a question.
Right.
That's sequential processing in action, handling information bit by bit.
Yeah.
Traditionally, this was done with RNNs and LSTMs.
That's right. But imagine reading a book and only remembering the last sentence.
Yeah.
You'd miss the plot. Right.
Yeah.
These older models struggled with long-range dependencies, connecting information that's really far apart in a sequence.
Yeah.
Then came transformers capable of processing information in parallel,
Okay.
like seeing the whole book at once.
So they have a wider field of vision, so to speak.
You do. They do.
But there's a catch, right?
Indeed, transformers, while powerful,
Yeah.
are resource-intensive.
Okay.
They're like a massive orchestra needing a huge concert hall.
Oh,
That's where RWKV comes in,
okay.
aiming to combine the efficiency of RNNs with the performance of transformer,
Got it.
like a chamber orchestra achieving symphonic grandeur.
Intriguing.
Yeah.
So how does this chamber orchestra actually work?
Well, let's break it down.
Okay.
Let's decode the acronym.
Okay.
RWKV stands for receptance, weight, key, value.
Okay.
Imagine a librarian
All right.
instantly recalling the most relevant information from a vast library
Yeah.
based on a whispered question.
I like that.
So, receptance controls how much past information is considered.
Right.
Weight assigns importance to different pieces of information, considering their position and learned parameters.
So it's not just blindly processing everything equally?
Exactly.
Okay.
It's like prioritizing the most relevant chapters when you're summarizing a book.
Got it.
And like a transformer,
Okay.
RWKV uses keys, which are kind of like tags,
Yeah.
and values, which are the content,
Totally.
to match the current input with relevant pieces from the past.
So far, so good. But how does it achieve that chamber orchestra efficiency?
That's where time mixing and channel mixing come in.
Right.
Time mixing handles interactions across the entire sequence,
Okay.
determining the relevance of past information using exponential decay.
Okay.
Think of it like an echo.
Okay.
The further back a sound is,
Yeah.
the fainter it gets.
So RWKV prioritizes recent information,
Precise.
allowing it to process things faster.
Exactly.
Okay.
This clever trick avoids the heavy computations of transformers,
Okay.
which would be meticulously analyzing every echo no matter how faint.
Yeah.
And that's what makes them resource intensive.
Makes sense.
Now for a little Feynman technique question.
Ooh.
How does this approach impact RWKV's ability to handle very long sequences
Okay.
compared to a transformer?
That is a good question. I'm sensing a trade-off there.
Perhaps.
But before we go down that rabbit hole, what about channel mixing?
So channel mixing, think of it as refining information within each word
Okay.
or token.
Yeah.
It's like the librarian carefully reading each relevant chapter
Okay.
to extract the most essential points.
I like that.
Working together, time mixing provides the global view,
Okay.
while channel mixing dives into the specifics.
So the two work in tandem, like a well-coordinated team.
Exactly.
This is a great foundation. But how has RWKV evolved?
Well, it's had some fascinating upgrades. We'll focus on RWKV5.
Okay.
We call it Eagle.
Eagle.
At RWKV6,
Okay.
Finch.
It's your
Each addressed limitations of its predecessors.
right.
Eagle introduced multi-headed matrix-valued states.
Well,
Imagine the librarian having multiple sets of eyes, each focusing on a different aspect of the information.
got it.
This allows for parallel processing,
Okay.
similar to a multi-headed transformer,
Okay.
but with RWKV's characteristic efficiency.
So it's like having a team of specialized librarians working together.
Exactly.
Okay.
And Finch took things further with the LoRa mechanism,
Okay.
which is low-rank adaptation.
Okay.
This lets the model dynamically adjust its memory based on context,
Interesting.
like a librarian reorganizing bookshelves on the fly,
Huh.
depending on the types of questions they're getting.
That's incredibly efficient. But what's fascinating is how this mirrors human learning.
Oh, yeah.
Think about how we get better at understanding things based on the situation or prior knowledge.
Right.
That's like priming or context sensitivity.
A brilliant observation.
Thanks.
Finch essentially learns how to learn,
Yeah.
becoming more adaptable.
Okay.
Now, another Feynman technique question.
Okay, hit me.
Imagine you're designing an AI assistant with RWKV.
Okay.
What tasks might it excel at? And where might it struggle compared to a transformer-based model?
Ooh, another one to ponder.
Yeah,
I'm starting to see the unique strengths and potential trade-offs of RWKV.
you're getting it.
But where does it fit in the broader world of language models?
It has fierce competition.
Yeah.
Linear transformers, Mamba, RetNet, and Hyena, to name a few.
Oh, wow.
They all aim for efficient language processing,
Okay.
but like different tools for different jobs.
Got it.
Think of LLMs as athletes.
Okay.
Transformers are marathon runners.
Okay.
Great endurance, but needing lots of fuel,
Yeah.
computational resources.
Got it.
RWKV is more of a sprinter,
Okay.
blazing fast for shorter distances.
So for quick responses or on devices with limited power, RWKD would shine.
Precisely.
Right?
And the math confirms this.
All right.
RWKV boasts significantly lower computational complexity, especially for shorter sequences.
Makes sense.
Now, one last question for this section.
Okay.
If you were building an LLM-powered app for a smartphone, what factors would make you choose RWKV over another architecture?
I'll keep those mental gears turning.
Please do.
But enough theory.
Yeah.
Let's see RWKV in action.
Right.
You mentioned it's surprisingly versatile.
Absolutely. It's not just a theoretical concept.
Okay.
We'll explore the real-world applications next.
I can't wait.
Welcome back.
All right.
Let's dive into the exciting world of RWKV applications. As you might expect.
Yeah.
It's making waves in natural language generation, particularly in chatbot development.
Chatbots are everywhere these days.
They are.
What's RWKV bringing to the table?
Imagine a chatbot that not only responds, but also understands the nuances of your questions and provides contextually relevant answers.
Okay.
RWKV is being integrated with knowledge graphs,
Okay.
allowing chatbots to access and process vast amounts of information to provide truly insightful responses.
That's a step beyond those frustrating chatbots that give generic answers.
It is.
Yeah.
It is.
What other cool applications have you seen?
There's a project using RWKV to power a sports-focused chatbot.
Oh, wow.
It can answer complex questions about teams, players, and even predict game outcomes with impressive accuracy.
For a field like sports with so much data and real-time changes, that's impressive.
It is.
Yeah.
It really highlights RWKV's ability to handle dynamic information.
It does.
Yeah.
And remember, RWKV is about efficiency.
Right.
This sports chatbot achieves high accuracy while using significantly fewer resources compared to larger models.
That's right.
It's like having a sports encyclopedia that fits in your pocket.
It is.
I'm starting to see the appeal for developers who want to build powerful but resource-efficient applications.
Right.
But it's not all about text-based chatbots, is it?
It's not. RWKV is also pushing the boundaries of chatbot interaction.
Okay.
There are projects exploring its use on platforms like WeChat,
Right.
where chatbots can respond with voice messages,
Wow.
stickers, and even generate personalized emojis based on the conversation.
That's a much more engaging and dynamic experience.
It is.
It sounds like RWKV is helping to make chatbots more human-like and fun to interact with.
Precisely.
Yeah.
It's about creating chatbots that feel less like machines and more like companions.
I like that.
Now, let's move beyond chatbots.
Yep.
What else comes to mind when you think of natural language generation?
Creative writing, perhaps.
You got it.
Okay.
RWKV is being used to generate everything from short stories and poems to full-blown web novels
Wow.
across various genres.
Right.
One project even uses RWKV to create interactive stories where the reader's choices influence the plot.
That's amazing. So it's not just about churning out text, it's about crafting engaging narrative.
That's right.
And I recall one of our sources mentioned music generation.
Absolutely. RWKV can compose music in various styles, even generating MIDI files that you can use in your own projects.
Wow.
Imagine an AI composer that can create custom soundtracks for your videos or games.
It's like having a personal Mozart on demand.
It is.
But let's shift gears now
Okay.
and talk about natural language.
All right.
Understanding.
Okay.
Making sense of existing text.
A perfect transition.
Thanks.
RWKV is proving its worth in this area as well.
Okay.
Think about virtual assistants that can understand complex commands like find me all emails from last month about the RWKV project, and summarize the key points.
Okay.
This level of nuanced language understanding is where RWKV shines.
Oh, it would save me so much time.
I know, right?
I could finally clear up my inbox.
Yeah.
What other practical applications are there?
RWKV is being used to analyze documents like research papers and legal contracts,
Okay.
extracting key information and highlighting potential risks or inconsistencies.
Wow.
It's like having an AI lawyer and research assistant rolled into one.
Now, that's what I call efficient. And speaking of efficiency, I remember reading about RWKV's use in machine translation.
Yes, machine translation is a complex task, but RWKV is proving to be a valuable tool.
Yeah.
One project uses RWKV for Mongolian Chinese translation, employing techniques like contrastive learning to preserve the meaning and context of the original text.
That's crucial, especially for languages with very different structures.
It is.
So RWKV is helping to break down language barriers and make information more accessible.
Exactly.
Yeah.
It's opening up new possibilities for communication and collaboration.
That's great.
But beyond these core areas,
Okay.
RWKV's versatility extends to a wide range of NLP tasks.
I'm intrigued. What else is it capable of?
Imagine a world where you can predict population growth trends based on census data forecast stock prices, or even have an AI assistant that helps you write code by predicting what you'll type next.
Wow.
All of these are being explored using RWKV.
That's incredible. It feels like we're on the cusp of a revolution in how we use language and information.
We are.
But what about the ethical considerations of such powerful technology?
Those are important questions to consider as these technologies evolve.
Yeah.
It's crucial to ensure they are used responsibly and ethically. But for now, let's continue our exploration and see how RWKV is being applied in the visual realm.
Computer vision.
Yes.
Now this I have to see.
I think you'll be impressed.
Let's dive into the world of images next.
Yeah.
All right, prepare for sensory overload, because we're about to see what RWKV can do with images.
Okay.
I'm fascinated by this because I always associated image processing with those complex convolutional neural networks.
It's true, CNNs have traditionally ruled this domain.
Yeah.
But RWKV is proving its mettle here as well,
Right.
handling visual data with surprising efficiency.
So what kinds of visual feats are we talking about?
Let's start with something close to home medical imaging.
Okay.
Imagine RWKV helping doctors analyze scans and images,
Okay.
potentially leading to faster and more accurate diagnoses.
Yeah.
There's a project called Restore RWKV,
Okay.
focused on restoring damaged or low-quality medical images,
Okay.
crucial for clear diagnoses.
That's a game changer, especially in critical situations where every second counts.
Exactly.
Right.
And there's BSBP RWKV, which combines denoising techniques with RWKV to improve segmentation in medical images.
Segmentation that's identifying different parts of an image, like pinpointing a tumor within a brain scan.
Precisely.
Yeah.
It's about making subtle but crucial distinctions.
Yeah.
Beyond medicine, RWKV is being used for 3D object detection, essential for self-driving cars and robotics.
So it can understand where objects are in space and how they relate to each other.
Yes, Lion, for example, uses a modified RWKV architecture to achieve highly accurate 3D object detection even in challenging conditions.
Okay.
Think navigating a busy street or a cluttered warehouse.
It's mind-blowing how RWKV can handle such diverse tasks.
It is.
From text to images, it's like a multi-talented artist.
And there's more.
Okay, what else?
It's even making strides in action recognition.
Okay.
Understanding movement and events within a video.
Hold on. It can interpret actions,
Yeah.
like distinguishing between someone walking, running, or dancing.
Exactly.
Yeah.
A project called TLS RWKV leverages RWKV to capture those temporal patterns,
Okay.
how things change over time.
Yeah.
This is crucial for understanding the flow of actions.
It's like RWKV can watch a movie and tell you not just what objects are present, but what's actually happening in the story.
That's a great analogy.
Thanks.
And another project, RuleVM,
Okay.
uses RWKV to monitor video content for violence.
Okay.
It combines visual cues with language-image alignment,
Okay.
connecting what's seen with what might be said.
That's fascinating.
Yeah.
It's analyzing both the visual and auditory information to make sense of the scene.
Uh-huh.
It's incredible how RWKV keeps pushing boundaries.
It is, while it's not ready to replace all existing techniques,
Yeah.
the progress is remarkable. It highlights the potential of a unified architecture for both language and vision processing.
So as we wrap up our deep dive, What are the key takeaways for our listener?
RWKV is an innovative architecture challenging the status quo, especially in tasks demanding both speed and efficiency. It's making waves in NLP, computer vision, and web applications,
Yeah.
with more groundbreaking developments on the horizon.
And to leave our listener with a final thought-provoking question.
Okay.
If RWKV continues its rapid evolution, could we see a future where AI assistants on our smartphones are as capable as today's most powerful LLMs, but without needing those massive data centers?
It's a tantalizing possibility.
Yeah.
The fusion of efficiency and power that RWKV represents could usher in a new era of accessible and personalized AI experiences.
It's been an incredible journey exploring RWKV with you.
The pleasure was all mine.
To our listener, keep those minds curious. Explore these fascinating technologies and see where they lead you.
Yes.
Who knows what amazing breakthroughs await?
Exactly.
Thank you for joining us on this deep dive.
Thank you.
Until next time, keep those learning gears turning.